a cosmic time capsule unveiling the solar system's age. Our solar system is incredibly old. Scientists use radiometric dating to determine the age of rocks. These rocks tell us that the solar system formed around 4.6 billion years ago. Our journey begins with the birth of our solar system, a cosmic event that set the stage for everything we know. The solar system formed from a giant cloud of gas and dust. This cloud, called a nebula, collapsed under its own gravity. As it collapsed, it started to spin faster and faster. The center of the cloud became incredibly hot and dense, eventually igniting into our sun. The remaining material formed a swirling disk around the newborn star. Over millions of years, this disk cooled and condensed. Particles clumped together, growing larger and larger. Eventually, these clumps became planets, moons, and other celestial bodies. Studying these ancient objects helps us piece together the history of our cosmic neighborhood. Planetary mysteries, unraveling the secrets of Mars and beyond. Our solar system is full of mysteries. Each planet holds unique secrets waiting to be unlocked. Mars, often called the Red Planet, has long fascinated scientists. Evidence suggests that Mars was once a much warmer and wetter place. It might have even harbored life. The presence of methane in the Martian atmosphere is particularly intriguing. Methane can be a sign of biological activity, but it can also be produced by geological processes. Scientists are working to determine the source of methane on Mars. This could provide valuable clues about the planet's past and the possibility of ancient life. Pluto, once considered the ninth planet, is now classified as a dwarf planet. It's a small, icy world located in the distant Kuiper Belt. Pluto's surface is surprisingly diverse, with mountains, plains, and even a heart-shaped glacier. Scientists are still learning about Pluto and its moons. Uranus, the seventh planet from the Sun, is a strange world. It's tilted on its side, with its axis of rotation almost parallel to its orbit. This unusual tilt gives Uranus extreme seasons that last for decades. Scientists believe that a massive collision early in Uranus's history may have caused this unusual orientation. Venus, our closest planetary neighbor, is a scorching hot world with a thick, toxic atmosphere. The Sun's energy, a star's powerful influence. The Sun, a giant ball of burning gas, is the center of our solar system. It's the source of energy that makes life on Earth possible. The Sun's energy is produced by nuclear fusion. Deep within its core, hydrogen atoms fuse together to form helium, releasing enormous amounts of energy. This energy travels through space as light and heat, reaching Earth and the other planets. The Sun's energy powers our weather, drives our climate, and sustains all life on our planet. The Sun also emits a stream of charged particles called the solar wind. This wind can interact with Earth's magnetic field, creating beautiful auroras. Solar flares and coronal mass ejections are powerful bursts of energy from the Sun. These events can disrupt satellites, communication systems, and even power grids on Earth. By studying the Sun, we gain a deeper understanding of the universe and our place within it. Jupiter's Great Red Spot, a storm of cosmic proportions. Jupiter is the largest planet in our solar system, a gas giant with a swirling atmosphere of colorful bands and storms. The most famous feature on Jupiter is the Great Red Spot, a massive storm that has been raging for centuries. This storm is so large that it could swallow Earth whole. Winds inside the Great Red Spot whip around at hundreds of miles per hour. Scientists are still trying to understand what powers this massive storm and why it has persisted for so long. Jupiter's swirling atmosphere is a tapestry of colors and patterns. These features are created by differences in temperature, composition, and altitude. Jupiter has a faint ring system, much less prominent than Saturn's rings. These rings are made up of dust and small rocks, likely debris from collisions between Jupiter's moons and other objects. Jupiter has dozens of moons, each with its own unique characteristics. Section 5. Our moon, Earth's constant companion in space. The moon, Earth's only natural satellite, has captivated humans for millennia. It's a familiar sight in our night sky, illuminating our darkness and inspiring countless myths and legends. The moon's gravity creates tides on Earth, influencing the rhythms of our oceans and shaping coastlines. It also plays a crucial role in stabilizing Earth's axial tilt, contributing to our planet's stable climate. Without the moon, Earth would be a very different place. The moon's surface is a desolate landscape of craters, mountains, and vast plains of volcanic rock. These features tell the story of a violent past, shaped by countless impacts from asteroids and comets. The far side of the moon is more heavily cratered than the near side, suggesting that it has experienced a more intense bombardment history. Section 6. Black holes, where gravity reigns supreme. Black holes are some of the most enigmatic objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes form when massive stars collapse at the end of their lives. The star's core collapses under its own gravity, crushing itself into an infinitely small point called a singularity. The singularity is surrounded by an event horizon, a boundary beyond which nothing can return. Black holes are invisible to telescopes that detect light, X-rays, and other forms of electromagnetic radiation. However, astronomers can detect black holes by observing their effects on nearby matter. For example, as gas spirals into a black hole, it heats up and emits X-rays that can be detected by space telescopes. Supermassive black holes are thought to reside at the centers of most galaxies, including our own Milky Way. They play a crucial role in the evolution of galaxies, influencing star formation and regulating the growth of their host galaxies. Section 7. The Asteroid Belt, a ring of cosmic debris. The asteroid belt is a region of our solar system located between the orbits of Mars and Jupiter. It's home to millions of asteroids, rocky remnants from the early solar system. Asteroids are leftover planetesimals, the building blocks of planets. They vary in size from small pebbles to dwarf planets hundreds of miles in diameter. The asteroid belt is not a crowded place. Asteroids are spread out over a vast region of space. While most asteroids are concentrated in the main belt, there are groups of asteroids with orbits that bring them closer to Earth. These near-Earth asteroids pose a potential impact threat to our planet. Scientists are actively tracking these objects to identify potential hazards. Section 8. Cosmic collisions, a threat to Earth. Cosmic collisions are a fact of life in our solar system. Earth has been bombarded by asteroids and comets throughout its history. These impacts have shaped our planet's surface, influencing its geology, climate, and even the evolution of life. While most asteroids and comets pose no threat to Earth, large impacts can have devastating consequences. The extinction of the dinosaurs 66 million years ago is thought to have been caused by a massive asteroid impact. This event highlights the importance of understanding and mitigating the risks posed by near-Earth objects. Scientists are actively searching for and tracking potentially hazardous asteroids and comets. Space agencies around the world are developing technologies and missions to protect our planet from cosmic collisions. Section 9. Curiosity, the driving force of discovery. Curiosity has always been a driving force in human history. It's what compels us to explore the unknown, to seek answers to the big questions about our universe and our place within it. The study of our solar system is a testament to human curiosity. From the first astronomers who charted the movements of the stars to the modern-day scientists who send spacecraft to distant worlds, our quest to understand the cosmos is an ongoing journey. Section 10. The Expanding Universe, a never-ending exploration. Our universe is not static. It's constantly expanding, with galaxies moving away from each other. This expansion was first observed in the 1920s by astronomer Edwin Hubble, who noticed that the light from distant galaxies was redshifted, indicating that they were moving away from us. The expansion of the universe has profound implications for our understanding of the cosmos. It suggests that the universe had a beginning, a point in time when everything was compressed into an infinitely small and dense state. This event, known as the Big Bang, marked the birth of space and time. The study of the expanding universe is a frontier of science, filled with mysteries and wonders waiting to be unraveled. Section 11. Conclusion, our place in the grand cosmos. Our journey through the solar system has taken us from the familiar to the unknown, from the scorching heat of the sun to the icy depths of the Kuiper Belt. We've encountered planets of unimaginable size and storms that could swallow our entire world. We've peered into the depths of black holes where gravity reigns supreme. As we continue to explore the universe, we gain a deeper appreciation for its vastness and complexity. We also come to a profound realization: we are a part of this universe, connected to it in ways we are only beginning to understand. The atoms in our bodies were forged in the hearts of stars, and the molecules that make up our world were once scattered throughout interstellar space. The study of the universe is a humbling experience.